Physical World, Chapter 1, Section 1, Digging Deeper, Earth's Pattern of Volcanoes and Earthquakes. In the Investigate, you observed a pattern of volcanoes and earthquakes. You saw that the volcanoes and earthquakes were concentrated along the edges of some continents. For example, you saw that there are many volcanoes and earthquakes along the western coasts of North and South America. You also observed that volcanoes were concentrated in a linear pattern. They formed straight lines along the central parts of many ocean basins. When you looked at the patterns on this dynamic planet map, you saw that the surface of Earth is broken into gigantic slabs. These gigantic slabs are called lithospheric plates. These plates move in relation to one another. The theory that explains this large-scale movement of Earth's lithosphere is called plate tectonics. Tectonics comes from a Greek word meaning builder. Geologists who study tectonics examine the structures and processes in the lithosphere. They study volcanoes and earthquakes and the forces and movements that create them. Geologists use patterns in the locations of volcanoes and earthquakes to define the margins or boundaries of lithosphere. Geologists use patterns in the locations of volcanoes and earthquakes to define the margins or boundaries of lithospheric plates. The patterns are also used as evidence to support their explanations about why these gigantic slabs of crust move. You will learn more about their sizes and motions in upcoming sections. Earth's volcanoes and their locations. A volcano is a vent or fissure in Earth's crust that allows magma, gases, and ash to escape from below the surface. Magma is the molten rock material generated within Earth. When the molten rock comes out of a volcano, it is called lava. Geologists have known for a long time that there are many volcanoes along the edges of certain continents. Figure 1. Lava flow occurs on the continents and on the ocean's floor. Okay, so here's lava flows occur on the continents and on the ocean floor. So here it is on the continents, and here it is on the ocean floor. Volcanoes can erupt under the ocean or on land. Volcanoes under the ocean form in the following way. All of Earth's ocean basins have a continuous mountain range extending through them. This range is called a mid-ocean ridge. These ridges are broad rises in the ocean floor. They are usually in water depths of 1,000 or 2,000 meters. They are 50,000 kilometers long in total. Figure 2 shows a vertical cross-section of a mid-ocean ridge. At the crest of the ridge, there is a steep-sided rift valley. Magma from deep in Earth rises up into the rift valley to form volcanoes under the sea. Volcanic rocks on the floors of all the ocean basins are evidence that there are more volcanoes underwater than on land. Volcanoes have also been observed by scientists in Volcanoes have also been observed by scientists in deep diving submersibles. A submersible is equipment that is intended for use underwater. At a few places along the mid-ocean ridges, as in Iceland, volcanic activity is especially high and volcanoes build up enough to form islands. Volcanoes. Let me scroll up a little bit so that as I read this, you can still see the diagram. Okay, here we go. There we go. Figure 2, cross-section of a mid-ocean ridge. There's figure 2, okay. Volcanoes that erupt on land are much more dangerous than volcanoes beneath the ocean. Eruptions along the western edge of the United States have formed the Cascades volcanic mountain range. They also form island chains such as the Aleutians in Alaska. Volcanoes like these are common in a narrow belt all around the Pacific Ocean. Geologists call this the Ring of Fire. A famous example of an eruption along the Ring of Fire was the dramatic eruption of Mount St. Helens in Washington in 1980. A small percentage of volcanoes occur in the interior of a plate. The Hawaiian Islands, shown in Figure 4, are an example. Studies of volcanic rock show that the islands get older the further northwest they are located. Only the youngest island, the Big Island of Hawaii, has active volcanoes. In Figure 3, the plates of Earth and the Ring of Fire around the Pacific Ocean. The circles show active volcanoes. How do geologists explain the pattern of the Hawaiian Islands? Deep beneath Hawaii, there is a fixed source of abundant rising magma called a hotspot. As a plate moves across this area, it passes over the fixed hotspot. Magma from the hotspot forces its way through the moving plate to form a chain of islands. The sharp bend in the chain was formed when the direction of movement of the plate changed abruptly at a certain time in the past. Far to the northwest, the chain consists of seamounts. Okay, so here in Figure 4, the Hawaiian Islands chain and the Emperor Seamount chain. Figure 5, satellite image of the Hawaiian Islands. Earthquake patterns and plate tectonics. Earthquakes are another geologic process that takes place on Earth's crust. An earthquake is a sudden motion or shaking of Earth as rocks break along an extensive surface within Earth. The concentration of earthquakes along plate boundaries is very high. As you read earlier, Earth's plates move relative to one another at their boundaries. In some places, two plates slide past one another. In other places, plates move away from each other or toward each other. These motions cause forces in the rocks near the plate boundaries. When the forces build up to be greater than the strength of the rocks break, causing an earthquake. The sudden release of energy as rocks rupture causes intense vibrations called earthquake or seismic waves that extend in all directions. So just going back a little bit, the concentration of earthquakes along plate boundaries is very high. See Figure 6. So here's Figure 6. And then, so here's the plate boundaries. So the red are the red lines are the plate boundaries. And then the yellow circles are the earthquakes. So you can see that the concentration of earthquakes is much higher along the plate boundaries. Okay, and here we go. Figure 6. The direction that Earth's lithospheric plates move are shown by arrows. The circles show earthquake locations. All right. Earthquakes usually occur at some depth below the surface of Earth. The place in Earth where rupture, the break, occurs is called the earthquake focus. Plural is foci. The epicenter is the geographic point on Earth's surface directly above the focus. The depths of the earthquake foci match the types of boundaries where the earthquakes occur. Figure 7, the relationship between the focus and the epicenter of an earthquake. Look at the relationship. Here's the focus. Here's the epicenter. So the epicenter happens above the focus. Earthquakes and volcanoes are closely related to the movement of Earth's crust. However, they do not always happen in the same places. During explosive volcanic activity, the crust can be fractured. This breaking of the crust is often accompanied by the release of seismic waves. Other kinds of volcanism happen without any great shaking of the ground. Movements of the crust that release earthquakes may occur without any volcanoes. For example, the movement of earth crust along the San Andreas Fault in California does not involve volcanoes. Figure 8, here's a photograph of the San Andreas Fault in California.